What if I told you that the universe began not with a bang but with a hum, a vibration, a resonance that filled all of space because in that first moment, space itself was infinitesimally small? It's a strange thought. We are accustomed to silence, but before any of that, before stars, before planets, before the very concept of silence could exist, there was a symphony of creation. This primordial hum was the sound of energy transforming into matter. How do we know any of this happened? We weren't there to see it. Our knowledge comes from something more profound, a cosmic echo. In the 1920s, Edwin Hubble made a startling discovery. Using the Hooker telescope at Mount Wilson Observatory, he saw distant galaxies receding. The farther away a galaxy was, the faster it was moving. It was a revolutionary idea. The universe was expanding. Loaf of raisin bread baking in the oven. As the dough expands, every raisin moves away. From any single raisin's view, all others rush away. If it's expanding now, it was smaller in the past. Rewind enough and everything was a hot, dense single point. This is the essence of the Big Bang. A hot, dense beginning should have released an immense flash of light. In 1964, Arno Penzias and Robert Wilson stumbled on this echo by accident. Instead, they heard a persistent, annoying hiss. It came from every direction, day and night. So, the universe is expanding. It started from a hot, dense point. This leads to the ultimate question. What was there before the Big Bang? The honest answer is, we don't know for sure. Our current laws of physics, including Einstein's theory of general relativity, break down at that initial moment, called the singularity. Time began with the Big Bang. Space began with the Big Bang. Asking what came before might be like asking what's north of the North Pole. One idea, our universe emerged from a sea of pure potential, a quantum foam. Tiny fluctuations of energy could pop into and out of existence. Perhaps one fluctuation was different. Instead of disappearing, it underwent rapid runaway expansion, giving birth to our cosmos. The pre-universal realm might not have had a before or after. It might have been timeless. If our universe could be born from such a fluctuation, why not others? This is the idea of the multiverse. Let's zoom in on that first moment. That first tiniest fraction of a second after the Big Bang began. The conditions here are beyond anything we can replicate on Earth. The entire observable universe, with its billions of galaxies, was compressed into a space smaller than a single atom. The temperature was trillions of degrees. Gravity, electromagnetism, strong nuclear force, weak nuclear force, were likely merged into a single, unified superforce. In this primordial state, there was no distinction between matter and energy. They were interchangeable. A seething soup of exotic particles. For every particle of matter, a particle of antimatter was born. Just after that initial moment, something extraordinary happened. The universe underwent a period of astonishingly rapid expansion, known as cosmic inflation. Visual timeline, tiny point, rapid blowout, grapefruit scale jump. In a fraction of a second, something like a trillionth of a trillionth of a trillionth of a second, the universe grew from subatomic to about the size of a grapefruit. This wasn't just a regular expansion. This was an exponential, supercharged growth spurt. It was as if a single grain of sand suddenly swelled to the size of the entire Milky Way galaxy in the blink of an eye. The leading theory, a powerful energy field, the inflaton, permeated space. The field acted like anti-gravity, pushing everything apart. Tiny quantum fluctuations, microscopic ripples on the inflaton, were stretched to cosmic scales. Those ripples became seeds of gravity. Over billions of years, gravity pulled matter to denser regions, forming the first stars, galaxies, and the grand cosmic web. After inflation ended, the universe was still an incredibly hot and dense place, but it was now much, much larger. It continued to expand and cool, but for about 380,000 years it was a completely opaque fog. The universe was filled with a plasma of free-roaming protons, neutrons, electrons, bathed in a sea of photons. Anytime a photon tried to travel, it would immediately bump into a free electron and be scattered. Light was trapped, unable to travel freely. Then, a critical threshold was crossed. After 380,000 years of cooling, the universe's temperature dropped to about 3,000 degrees Celsius. It became cool enough for nuclei to capture electrons, forming the first neutral atoms. This event is called recombination. Suddenly, with free electrons bound into atoms, the photons were set free. The fog cleared. The light released then is what we now observe as the cosmic microwave background. It has been traveling unimpeded for 13.8 billion years. As space expanded, these light waves were stretched out, shifting from visible light into microwaves. This is why Penzias and Wilson detected a faint microwave hiss. The standard Big Bang story is elegant, but the universe is rarely that simple. There are strange theories and wonderful theories that explore the what-ifs of cosmology. One such idea is the Big Bounce. Instead of a singularity, some models propose our universe is part of an eternal cycle of expansion and contraction. In this scenario, the Big Bang wasn't a beginning, but a bounce from a previous contracting universe. Another fascinating, highly speculative idea is that our universe might be a hologram. The information in a 3D volume could be encoded on a 2D boundary. It's a wild thought, but it comes from attempts to unify quantum mechanics and gravity. Then there's the eerie concept of phantom energy, dark energy that could change over time and lead to the Big Rip. These theories are on the cutting edge of physics and they may or may not be correct, but they push our understanding and force us to ask deeper questions. Despite all our progress, the universe still holds deep and profound mysteries. The more we learn, the more we realize how much we don't know. Perhaps the biggest puzzle is the nature of dark matter and dark energy. All the stars, planets, galaxies, everything we can see make up only about 5% of the universe. About 27% is dark matter, an invisible substance whose gravity holds galaxies together. The remaining 68% is dark energy, the mysterious force driving the accelerated expansion of the universe. Why are the fundamental constants so perfectly balanced for life? If gravity were a tiny bit stronger or weaker, no stars, no life. It seems statistically unlikely we are alone. Yet we have no definitive evidence of extraterrestrial intelligence. This is the Fermi paradox. Answering these questions is the great challenge of our time. They drive our telescopes, our probes, and our imaginations. So where does that leave us? We are adrift on a small world, in a minor solar system, tucked away in an ordinary corner of a vast and ancient cosmos. We have pieced together the story of our origins, from the first instant of creation to the emergence of consciousness. We are made of stardust, the remnants of cosmic explosions, and our existence is owed to a slight imbalance at the dawn of time. We have discovered the universe is expanding and accelerating, driven by a mysterious force we do not understand. Big freeze, the universe grows cold and dark. Big rip, everything tears apart. Big crunch, gravity pulls everything back together. Our destiny is tied to the destiny of the cosmos. Will we remain confined to our single, fragile planet, or will we venture out into the vastness, carrying the legacy of our cosmic origins to the stars? Never stop looking up, never stop asking questions. The cosmos is not just out there, it is within us. So I leave you with this final dramatic question. As our universe rushes toward an unknown future, what role will we play? Our journey of discovery has just begun. If you enjoyed this deep dive into the Big Bang, subscribe for more cosmic mysteries, like the video, and share it with someone who wonders about the universe. Stay curious.